The stream is live. It's yours.
Cool. Great. All right. Thank you, everybody, for coming tonight. I know you're not just here for me, but I'm going to pretend like you are. One quick plug before we get started. I work for SAP Concur in Bellevue. We are hiring. One thing that I want to note is, so we use the energy stack, Node, React, Redux in GraphQL. Most of my team has graduated from boot camps, so my company likes to say that they like to give people chances. So if you come from a non-conventional background and you are looking for a job or you're struggling to find software jobs, let me know. My Twitter was at the front of the slides. I'll be sharing the slides, and you can find me on the meetup. Just send me a message. All right, so this talk is called Need for Speed React. And all of this came out of work that I did shortly after I started my job. So this is some of my first revelations with the React framework, fresh out of college. So I found this online, and this is what I'm going to call React in 3 stories. You set the state's dirty, it gets re-rendered. And the idea is there is some performance stuff that we can optimize in between these 3 steps. Poor performance is a liability, and I have 3 bullet points that prove that. The BBC says that they lose 10% of users for every additional second their site takes to load. Google found that 56% of mobile websites are abandoned after 3 seconds of loading, and delays of 500 milliseconds cause a 26% increase in frustration and 8% decrease in engagement. So what I'm trying to make the case for is these kind of frustrations are really important. Users will abandon your application. The more frustrated, you've probably had frustration with slow software. And even if you can't call out where these slowdowns are specifically, you just know that when you are using this application, you get frustrated. And so that is something that we want to help with the user experience. So a tale of 2 horses. The initial part of the story of this talk came from my boss had gone back to, I believe he's from Ohio, and he was back taking care of some family stuff, and he joined in our stand-up meeting, and at the end of the stand-up he says, hey, somebody needs to look into this typing delay that we're seeing when we're on this application that we were building. And all of us pulled up the application and we started typing in every single place, and we could not figure out where he was seeing a typing delay. We were looking at we call it list builder, so it's just maintaining lists. We type in the search area, type in the add, the edit, all of these places, no search delay. You probably can't tell, but I have about a $3,000 machine, and his is a few years older. So he has a 2013 MacBook that's a 13-inch MacBook. And between the 2013 13-inch MacBook and my 2016 15-inch MacBook, there were delays. And that was one of the first things where I was like, well, no duh, we're not seeing this. We aren't in that Mitsubishi consumer. We are in a race car. And the other thing is that when you are on a high-performance machine on a high-performance network, so such as a corporate network, you are not going to see those issues. So as I was bringing up those 3 bullet points of the frustrations, as you're developing, you might not be experiencing the same things that your user are experiencing because you are on this fast track and not this network. This network is closer to what I have at home or when I'm on 3G. And as app developers and people who are really hopefully creating fun and exciting apps, we need to make sure that we are building for the people who are using our networks or using our applications. So before I get into too much, one of the things when I was doing all my research for this was measure first. If you just start going out and you start hammering your application with performance boosts in every single area, you're not going to know what before and after looks like, and you don't even know if you're putting in the right performance benefits. So measure first, and that's the first thing that we're going to talk about. How many of you have used Chrome DevTools? Yay! How many of you have used this profiler specifically? Yay! So this was what I used when when he mentioned to me that he was having issues with this, and we didn't know where these slowdowns were coming from. Because it was, on his machine, it was really the faster you typed, the slower the application was, the more there was a key delay in just trying to type into a search bar anywhere on the application. So one thing that I wanted to highlight about this, and this is in the Performance tab of Chrome DevTools, and it's the same place as this. And more specifically this, you have two options, network and CPU. So if you are a data-heavy application, you can simulate slower networks. And so Chrome will go and make these requests for you and give them to you on a slower basis. So you can take your application and see what it looks like when your network is really slow. You can see what parts of it don't load fast. Or I've been on plenty of websites where the HTML loads really quickly and then the CSS takes a little while. And so if you want to know what that looks like, that's where you can simulate that. Same thing with CPU. That's what I had to do to debug all the stuff with that application that we were seeing. Is I had to bring my machine all the way down to a 6 times slower decrease in CPU, and then I could finally start. When I started typing, I actually saw those delays. This is an example of the profiler. Specifically, what you do is you press the record button that's right there. Do whatever interaction you want to measure on your application, and then after you're done doing your whatever interaction you're trying to record, you press stop. It'll take a little while, and then it'll bring up this. It gives you frames, so like you can see what I'm doing in this video is I'm just going from one station to another and recording that interaction. And all of these, I think this is a firewall. Can't remember what kind of graph this is. Fire chart something. That tells you exactly how, what function took the longest, what it's doing. Is it displaying? Is it loading? Is it rendering? Is it doing JavaScript-y stuff? And an easier way to visualize that is, so this, all I'm doing is I'm scrubbing the timeline, and you can see just the different things. And what I really want to call out is this right here. So it tells you the start time and then the end time and the percentage of what the browser was doing at that time. So you can see as I'm doing all this stuff, that was just Pandora radio stations. It's spending a good chunk of the time sticking in the scripting portion. That's pretty typical, I would assume, for a very heavy application like Pandora. But if you're on a static site that's not doing a whole lot of business logic, it shouldn't be that large. I think that's all I want to say about that. There are other tabs right here, the bottom up, call tree and event log. If you really, really, really need to dive deep into what calls are happening when and how long they're taking, you can look there. As of React version 16.5 and up, they've bundled the React Profiler. And the React Profiler is very similar to the Chrome DevTools Profiler, but for React, as you might imagine. The record button, same thing. You press record, you go do your interactions, you stop it, and you can look at what happened. This is an example that I took. Actually, I took this right off of the React website. This isn't even my stuff. But you can see how much time each function took and what it was doing at that time and what each render takes. So when we were doing the key press slowdown, we were seeing every time you pressed a key, the slowdowns there were just more slowdowns. And so each render took longer. And so, you go from like the 120 frames per second to, like 1. And that's what we were starting to see. So before I move on, this is your measure first. So when you're doing things, I took a few statistics classes. Actually, I took one statistic class twice. So I hate I hate doing that kind of stuff. But I just jotted everything down in Excel and said, this interaction took about this much time. Some people have it down to a science. I do not. But I got it using these two tools. I did get a general idea of what was happening when I was navigating my application. So as far as performance goes, I kind of broke it down into three things. There's the server itself, file transfers, and then the code. I do want to talk about the first two parts because those do affect the overall feel and performance. So the server performance, we live in a world now where we are probably not hosting our own things. Most of my company is moving to AWS, but we have data centers, and so the idea of production servers are largely removed from us. As developers, unless you have a side project, you're probably not working on the production machine itself. So some of the benefits that you can do if you are considering is how close is your server to the user. Netflix is a good example. You can imagine if Netflix had one data center in one piece of the world and everybody was going to that one point for all of their data, that network would be so congested. But what they do is they break it up and they put all of their content all over the world so that when you want to go get your content, all you have to do is go to wherever, they're called content delivery networks, CDNs, whichever one is closest to you, and you're only grabbing data from something close to you and not reaching all the way across the internet to do so. The load on the server. What else is running on your server? If you have a bunch of other things going on the server, that's going to slow it down. That's going to cause delays. And then server configurations. These are just things that, this isn't a very technical slide. These are just things that if you are really interested and you have control over these things, you can go Google them. But a lot of servers will give you, I know Nginx does, gzip compression for free. So if you're sending text files, you can enable compression and not have to worry about the doing it yourself. Like the servers will take care of it for you. So I've tried this joke twice and it failed. The internet is not a big joke. It's not a big truck. It's a series of tubes. Be proud. I was really hoping that. So, just sidebar. There's a classic internet meme of a U.S. senator describing the internet, and he says it's not a big truck. It's a series of tubes. They auto-tuned it. They did everything that they could to it. It is a legacy meme, I would say, obviously. So like I said, compression. If you are sending raw bytes across the internet and you're sending large packages to a browser, that affects the load time. That is 3 seconds of loading. On a 3G network, that's 3 seconds isn't hard to do on a 3G network. So you want to make sure that when you're building your application that you are keeping in mind what you are actually sending down to the user and compressing where you can. Images and videos, whenever I do anything with video, I upload it to YouTube and then I do a YouTube embed. YouTube is better at hosting videos than I am. End of story. Images, don't take images off of raw images off of a phone or a nice camera and put them directly on the internet. Run them through something first, please. There have been websites that I go to where everything loads really quickly, and then I get line by line by line, this 10, 20 megabyte image. And another thing that is tangential to performance is a lot of people on mobile data plans have data limits. So if they are going to waste 50 megabytes on one image that you forgot to compress, that would be an issue. And then JavaScript packages. Is everybody familiar-ish with Webpack? Cool. I'm not. I know I know enough about it to speak to it, and that's it. No questions. Cool. So actually getting into the nitty-gritty React-y stuff that you are here for. So the three things that I have kind of identified as the pillars of performance are unnecessary renders, poor code design, and then your build size. And I think, yes. So people who've used, how many of you have already used the React dev tools? Not Chrome, but React dev tools. Cool. So I encourage everybody who is building a React app to go look at it. You can install it in Chrome, and then I think it has like a little Reacty logo, and whenever you go to a website that's using React, it goes blue instead of gray. And then you can start exploring this. So Pandora is a React app, and I opened up the DevTools. And so one thing that you can do with the React DevTools is highlight updates. So anytime a component updates, it'll draw a little box around it. So I'm just doing some basic interactions. I believe I press play. And so, every time that the tick, the whatever you want to call the bar that shows you where you're at in the song, yeah, that. So anytime that updates, it'll update, which makes sense. When I scroll, it does updates, which is interesting. It's interesting that, so I'm scrolling here now, and it's the now playing in my stations are, the components up there are re-rendering. Do I do anything interesting here? Yeah, so I just, more of the same thing. When I highlight, you can tell that they're doing some logic and re-rendering those components. I went to Khan Academy's website, and you can see me typing, and it's doing those re-renders. For some reason, when I scrolled, it was re-rendering. And this right here, you can see where I type in that search bar. This is what told me what the issue was when we were doing it. So some context. So this list builder, SAP Concur is a travel and expense company. And one of the things that we let people do is make lists. Lists can be 5 columns deep. So United States, Washington, Seattle, blah, blah, blah. And so they can have child elements. And I think you can have up to 10,000 items in each list. And as developers, we put 10,000 items in each list, maybe 1,000. And so what was happening was we are doing all of our validation stuff in Redux. So we have it stored, and anytime you type, it was causing a re-render, and everything was re-rendering. Fun fact, browsers do not like to re-render that many items. So each component, 50,000 worst case scenario, individual list items that have to re-render, in addition to all the overhead that comes with the application itself. That was causing some slowdowns. And this is exactly how I saw that, is every time I typed, every single thing would re-render. And the more I typed, the more red. So I don't know if you see any red on this, but you can see when it goes red, that's when it's saying that this render took a long time. And from what I understand about React is the renders are not synchronous, so it does them as eagerly as possible. So basically, there's just a pipeline of renders that get pushed into a queue, and then they just take forever to do. How many people have worked with should component update? Perfect. Not enough people. That's great. So should component update, does anybody want to take a guess at what it does? Yeah, exactly. So you are telling your individual component, should this component update? The default implementation is should component update return true. That is what we were dealing with, is React, our entire React application and every component in it thought that every time the props changed, it needed to re-render. Every single time. I don't actually know why this is, and if you have any ideas, talk to me afterwards, because React also ships with React.PureComponent. So when you're doing class extends React.component, you can also do React.PureComponent. And PureComponent looks at the current props and the next props. If they are different, it will re-render, otherwise it doesn't. So by putting this on a lot of our components, we saved most of our renders. It was actually, you could actually start typing, but it was still slow. And the reason why is because with the way that we were passing in props and changing props, this strict comparison of current props and next props was not always guaranteed to be the most optimal. So there's a custom implementation that you can do. So you do the same on the first line, should component update, current prop, next props, and then knowing your application, you can say, you can reach into your props and say, is this the same? true or false. So you can say, so for ours, we were doing, like, we had search criteria, adding, editing. So I just went through the entire app and said, any special time when we can not update, don't do it. And that saved most of it. So where you were seeing that before, where every single thing was updating, the only thing that was updating when I was typing was the component being edited. And that was a really good place to get to. And it was fast on, we even tried it on like an old Chromebook, just to see how fast it was, and it got us to where we needed to be. How many of you are familiar with the concept of memoization? Okay, so the idea is basically caching for functions. If you can say that a function, given the same input, has the same output, you can store that. You can store the output given that parameter, and then call it later. So this right now is a common enough way to explain it, and it's using the Fibonacci sequence, so or factorials. So factorial 6 is the factorial 4 or 5, 4, 3, 2, 1. And so as you do these things, you can start saving things and have those optimizations as you're doing future calculations. Don't do work that you've already done again. In Redux, this is called reselect. So if your application has, if you do use Redux, you can create selectors that use reselect, where you give it the state and then whatever parameters you're looking at for your selector, and it will say, oh, hey, I've seen this state, this in these parameters before, here's the result. My team uses selectors very liberally, almost everywhere. A lot of them are just reaching into a specific part of state. But for some of them, we are actually calculating something that's a little less trivial. And so for all of those, we can just go and reach in, because every re-render will cause a call to, your selectors will run again. And so the less time you can spend in your selectors in Redux, the better. And so you can just get some freebies as far as performance goes there. Code splitting, hot topic. How many of you have heard of it? Okay, so this goes back to that Webpack thing. I have not done the configuration myself, but the idea is when you are bundling your code all together, and so you have this big, have this big .js that has all of the code for your application in one spot, and it's really nice because you only have one and you pull it down. But the thing is that the bigger it is, the harder it is to get down. So the good thing is it's all done in one request. The bad thing is that request is massive. Another way you could do it is every module that you have can be put into a specific JavaScript file, and then you grab every single one. So you don't have one big one, you just get it per module, and you only get what you need. But the more requests you have in the browser, the more overhead that you are putting. And so the way that it's recommended is putting your modules into chunks. So you only get what you need, and you're doing less requests, so it's less overhead. So you are bundling together some of the like functionality. I think that the equivalent is like when you visit a page, all of the JavaScript for that page is contained in one module. And so when you get there, you pull that all down, and you're not pulling down unnecessary JavaScript files. So yeah, the less load time, the better. So getting back to the beginning, you really want to get to the point where these re-renders are not causing your slowdowns. You don't want to have things re-rendering that don't need to be re-rendered. I feel like I've hit on that enough, but as I was looking at a lot of the other React applications that have been built, that's exactly what we're seeing is you're doing all of these re-renders that are causing slowdowns all over the place. And so the more selective that you can be with your renders, so adding those conditionals in, will speed things up, especially if you have an application like ours where you have an unholy amount of components on the page. Not everything is a list, but that's a good case where you are going to see that you need to do those updates. And that's me. SAP is hiring.